Hello, calculus students. I'm doing number 3 of related rates. I want you to realize that these are classic examples, and you can go online and find some good videos from Khan Academy. All you have to do is, you have to plug in related rates, type that in, and type in ladder problem or sphere problem or balloon problem. They're all there. Probably even better than what I'm doing, but I'm just working this worksheet. And this is your classic ladder falling down the wall. A 13-foot ladder is resting against a vertical wall when the bottom of the ladder begins to slide away from the wall at a rate of 1 foot per second. A, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall? B, how is the enclosed triangular area changing? And C, how fast is the angle between the ladder and the ground changing at the time when the ladder is 5 foot from the wall? So let's first get a picture of this. Here's my lovely picture. All right, this is number 3. Here's my ladder. Here, there's the floor. Here's the wall, and it's leaning up against the wall, this ladder. And I decided to call this y, that distance from the tip of the ladder to the floor. And I've decided to call this distance from the wall to the bottom of the ladder x, since that's the y-axis and the x-axis. And of course I kept mixing it up, but that's okay. And the ladder I'll call z. Why not? We've got an x, a y, and a z. And this is what's happening. The ladder is sliding, so it's down further on the wall. And notice that this x distance is getting larger as the y distance is getting smaller. And the ladder is constant. And here we've got the last one. I've kind of got a little y and a longer x where the ladder almost hits the wall. And each one of these, the angle between the floor and the ladder is, we're going to be looking at that angle. Notice that it's decreasing. So the 3 things we're looking at how y is changing, and notice that y is decreasing. And we're also looking at the area. So look at that red shade right there. The area is it increasing? Is it decreasing? It depends on where you start. It could be increasing, could be decreasing. The ladder could be much higher against the wall and you'd have a less of an area. So what happens is that the area increases and then at some point it starts to decrease. And then finally the angle. All right, and notice the angle definitely decreases. So part A is really asking about how fast the top of the ladder is sliding down. Right here, how fast is the top of the ladder sliding down? So we are looking for, and that's at z is equal to, well, we know z is equal to 13. That's given. That's how long the ladder is. And we're also given that dx dt, it's sliding away from the wall at 1 foot per second. And we're supposed to find dy dt. That is this change. It's decreasing. We're going to find out when x is 5 foot. So we need a relationship between x and y and z, and you guessed it, it's the Pythagorean theorem. So we're going to write down, oh, actually I summarized everything. B is what's dA dt when x is 5 feet, and C, what's d theta dt when x is 5 feet. So let's take a look at the first one. X squared plus y squared equals z squared. Now z is constant. Z is not changing. X and y are changing, but not z. So I'm going to go ahead and put the 13 in there. And that gives me x squared plus y squared equals 169. I'll look at this in a minute. And this is the relationship. We're going to find the derivative with respect to t. So derivative of x squared is 2x, and then you've got this dx dt by chain rule, plus 2y dy dt equals, and then the derivative of that is 0 on the right hand side. And this is when I start filling things in. I have x that was given to be 5, and that's what I did, this little triangle over here. That was given to be 5 feet. And I had to find y by substituting in the fact that that was 5 and that was 13. So I did 5 squared plus y squared equals 13 squared and got y is 12. So I was able to put in the 2, the 5, And the dx dt was 1. Remember, it's falling at 1 foot per second. And then this is 2 times 12 times dy dt. Now we have to solve for dy dt, so I just kind of did 2 times 5 times 1 and got 10 plus 24 dy dt. And to solve for dy dt, I subtract 10 from both sides and divide by 24, and that gives us negative 5 over 12. Now what is the unit on this? All right, y is measured in feet, and t is measured in seconds. So that should be feet per second, and that's what I wrote down. The ladder is sliding down the wall at 5/12 feet per second. I'm going to pause, and then I'll come back for part B.